For step 2, you want to calculate the total sum of squares. The total sum of squares gives us an idea of the total variability, total variation in our outcome. What we're doing is we're using that overall or grand mean as our benchmark, because that's sort of the basis for which we say, what's the total amount of variability in our sample? So we're going to take each individual observation, see how far off they are from that mean by subtracting that mean. Okay, so a larger difference indicates that person or individual is really far from that overall mean. And then we're going to square that difference. The reason we square is so that all these different values don't cancel each other out when we add them up. So we get all these positive values. And then, of course, we add them up. So just to be clear, we take each individual observation, subtract out the overall mean, so we get a different sort of a distance from each individual from the overall mean. We square them, we add them up. That's the total sum of squares. It's a measure of the total variability of our data. So in this toy example, the overall mean is 6.5. Then we take each value of the outcome from 1 to 12, because those are the values of our outcome. And for each value, we subtract the mean, square it, all the way up until the value of 12. And so we get this value of total sum of squares of 143. Again, this is the total variability of our data. Again, this should be familiar to you, because this is what we did when we calculated variance. We're just saying how far off is each individual, and then we're saying we're going to square these. So because if you don't square these values, they're all going to cancel each other out. We want a positive value for the total sum of squares. The important point here is that the total sum of squares, you can think of it as being the sum of the variability within each group, as well as the variability across or between each group. That's a key part of analysis of variance. That's really the fundamental aspect of analysis of variance. We can visualize the total sum of squares for our data set using this graphic. The dotted line, that represents the overall or grand mean of 6.5. Then you can see for each group, we have these 4 different observations. So for group 1, we have values of 1, 2, 3, and 4. For group 2, we have values of 5, 6, 7, 8. And for group 3, we have 9, 10, and 11, 12. So you can see each group has a set of values that are higher. The important point here is that for each observation, for each one of those dots, we're comparing those values to that overall or grand mean. We're saying how far off is each individual from that overall or grand mean.